All right, so this is for Thursday. I'm doing a little different this time. I'm going to try and speed this up. So on the wrap up screenshots, I do it four at a time. So I save space uh, on the canvas, but I'm going to just put those, and I'll talk about those because that pretty much. Then I'll add some color to it, but I'll that pretty much is what happened today in class. And so I'm trying to limit this down to, 20 minutes if I can. All right, so here we go. Let's share the screen. First set of images has the opening screen. It's for Thursday, class number 7. I wanted to show you that just to, because we are going to use Expo markers, and I still think you ought to probably buy your own, just so you can be sure that it's not contaminated. But I am going to, and I did this tonight too before I left, or today. I'm going to put all the dry erase markers that we have used that day into the into the Goggle storage center that has UV light. And so I'm going to hit these dry erase markers for 15 minutes every day with UV light. So in the morning, then I'll put them in the clean bowl, and as we use them, we'll drop them in the dirty bowl. And hopefully that'll allow us to continue to go to the board, because going to the board is a crucial part to my class. All right, next set of screenshots here. I did this on Wednesday in group 1, so in Thursday in group 2, I went and showed the new modules and how I did the wrap-up videos and all that. Also, I showed here. Let me get this little pointer. Okay, I showed the key. So 1.1 now has its key, the key posted. I want you to go back and look at it. You have your packet with you, so you should be able to always go back and check keys just to see, make sure you're doing it right. You don't want you to study the wrong thing. And then over here, this 50-50 point cushion, 50 out of 50. So everybody got 50 out of 50 points put into Infinite Campus. And that is that's so when, I think next week is the first week of eligibility. And I don't want people to be eligible just because they're missing one assignment. Your grade's really volatile early on in the semester. So I usually put in a cushion. So people's grades went from a D to an A or a F to a B. So the thing about this is great, except that after you turn in after packet 1, which would be, I think that test now, I have it set for October 8th. And that's a 250 point test. So these little quizzes are, 20 points or maybe 15 points, 12 points. That's nothing. 250 points is a real test. So if you're blowing off quizzes or just, not really paying much attention to them, it's going to come back and bite you October 8th. So, and also October 8th, when you'll turn in your packet 1. So those 8 sheets, and then maybe 9 sheets by now, I don't know, or 10 by the time we get around to that. But we'll put a cover sheet on there and staple it all together. And you'll turn that in with your notes. You'll staple your notes on the back. And so, except for my scribes, I've had 2 people so far have inquired about being class note takers. So anyway, all of this is nice to have, but that'll go away after sometime, or probably mid-October. That'll go away. So you'll need to have your grade cushion by then. And over here, I just wanted to show some more examples. We did this on Wednesday in class, where we plotted. Once I gave you an equation, you had to plot the graphs, and then I gave you graphs, you had to plot the equation. Well, on Thursday, that was group 1. So I'm hoping that group 2 watched that. But then on Thursday, I went ahead and had group 2, which is in here somewhere. Here it is. We did different ones depending on what class we're in, but let me blow this up. This was, I think, 3rd hour, where they had to go in and go to the board. I wanted to give everybody a chance to go to the board and practice, that. So everybody went up the board and they try to figure out the equation that goes with these 2 graphs, these two lines. And we're filling them in this form. And basically, it's just a matter of putting the slope into this yellow box with units. The units here would be kilometers per minute, and putting the initial position, which in math you would call the y-intercept, but this is actually x for us, x versus t. So you put your initial position in this box, and with units. So like this is 5 kilometers, we go here, and then -10 for the red one, -10 kilometers, we go there. So you put that in, and they had to go to the board, they had to get in, and they did really well. They did really well, I thought. I was proud of them, the kids that went up to the board. Now, somebody had this. They say, well, it's -3/4 kilometers per minute, plus 5 kilometers for their blue line. Well, if that was a test and it was early on in the year, you'd probably lose. If it was worth 10 points, you might lose 1 point. Because this, if you do this in industry, when you're an engineer, this will get you thrown in jail, or it could. It'll certainly get you sued because you are 3/4. We can't use fractions in here unless it's a coefficient. We'll talk about that in a second. But unless it's a coefficient, we can't use fractions. And here's the reason. When you say 3/4, and it's a measured number, we're assuming that we're assuming that kilometers here is measured and minutes is measured. So when you have, so in this case, the reason where they got that -3/4 was you drop 15, you run 20. So -15 over 20 is -3/4. And that seems right. And it is mathematically, but it's not for engineering, because we have we have accuracy. These things have to be accurate. So let's go over here. So when I say 3/4, that means 0.75 with an infinite number of zeros. It means you're saying that you are infinitely correct on that. When in reality, it totally depends on what kind of instrument you used. Is it 0.75 kilometers per minute? Is it 0.750? Which one is it? This one might have been figured out with a $10 instrument. This one might be a $100 instrument. This one could be a $1,000 instrument, and this one could be a $10,000 instrument. So it's important, and if you try to give that as your data, a good lawyer then would come along and say, well, wait a minute, you're committing fraud because you are saying that your values are infinitely correct. You're telling me that you used a $1 million instrument to find this out, when in reality you used a $10 instrument. So we'll get to that more later, sort of a preview. Something called significant figures. If you've had chemistry, you might have barely talked about it one day. If you're in AP chemistry, you'll talk about it quite a bit for labs. So in here, occasionally we talk about it like it's important when we go to the stadium. There's some things that we need to be very careful on, but I at least want you to be aware that we don't do fractions. Like the only time we do fractions is when I have something like this, but this came from math. So this came from a derivation, a math derivation. So if it's pure mathematical, then yes, you can have fractions because they're coefficients. Okay, hold on, I'm getting too far. This came from a math derivation. And this 1/2 is a coefficient. Now coefficients mean, the word coefficient means a number with no units. Okay, no units. So coefficients come from math derivations. They also sometimes, if it's a ratio, you'll have something called coefficient of friction, and that is a ratio of forces. And so that ends up with no units. So I can't say that coefficients always come from math world. Sometimes they do come from experiment, but when you divide out the units, you have a coefficient. If it has units, then it's called a constant. Okay, but more about that later. And here's the final panel of always try and do 4 on these. So some more examples. This is from Facebook from last year. I want you to have plenty of examples. So if you're trying to figure out, like, what you ought to do on this is cover, cover this up with your hand or whatever, and then try and figure out what they are. Then you can come over here and look and see what the equations should be, because you need practice. So this, more examples. Once again, either cover up the graphs and try and draw them, and then, or else cover up the equations. And then we spent some time later on going over metrics. We didn't do much on sheet 1.3, but we started talking about the French Revolution, where metrics came from, and I went through a little routine on an old Mac Classic I bought back in 1989. I was the envy of all of Norman High School because my computer could hold 40 megabytes of data. And I thought I would never run out of room at 40 megabytes. Well, now my test documents that I put together I just looked at one a little while ago. It's 160 megabytes, one document. So I could only get 1/4 of a test on there now. I mean, a typical song you'd hear, on Spotify is 4 megabytes. So this is $1,000 computer system back then, would hold 10 songs. So we've come a long way as far as electronics go in Silicon Valley. But so we went through all this to explain the difference between, we started talking about picometers, and that's a trillionth of a meter. That's distances between inside an atom. In that situation, you'd be talking quantum physics. But then we talked about nanometers, nanoscale. We talked about the coronavirus and maybe what the size of it is and what would make it airborne. If it's on the nanometer scale, I think I asked the class to look it up, and no one really caught it in time. We were kind of in a hurry, so we kept moving. But if somebody wants to figure out what the diameter of the coronavirus is, then we can look at that on scale tomorrow. And then if you compare that to air molecules, oxygen and nitrogen, they're both diatomics. But then look and see what their diameters are, and then you can look at kinetic theory and start to figure out, well, being slammed into by oxygen and nitrogen, and the coronavirus molecule could stay up for a certain amount of time, and see how far it could go. Just kind of interesting aspects to physics when you apply it to even chemistry and the atmosphere. All right, and biology. All right, so we talked about picometers, nanometers. We went to micrometers, which is 10 to the negative sixth, and I showed them the scale hanging from the ceiling towards the front of the room over there by the red equation. And I'll put that scale. That scale will always be up there in the room. And I'll also put it on, you'll have equation sheets. You'll have it on tests and stuff. I don't expect you to memorize it, but you probably will eventually. So what we got to know is we start at the low end, which is picometers. Then we go to micrometers, nanometers. Then we go to that's 10 to the negative ninth. Then nanometers is 10 to the ninth. Micrometers 10 to the negative sixth. Millimeters 10 to the negative third. And then we stick in centimeters because it's so common, 10 to the negative second, or 100th. And then we go to meters. Then we go kilometers, 1,000 meters. Megameters, that's 1,000,000. Gigameters, that's 1,000,000,000. And then terameters, that's 1,000,000,000,000. So we would go all the way from picometers on the small scale to terameters on the large scale. So for terameters, you're talking about distances from stars to planets, or between planets. Reason I was bringing up my computer is it was mega bytes, which is 10 to the sixth bytes. Most of your papers you write for English are probably on the order of around 50 kilobytes in size, maybe 100, depending on how long it is. So, you can get a lot of, if you just words. Now, when you put graphics in, and especially movies, I mean, you're looking at gigabytes there. So that's part of my problem with Canvas is I can only get 524 megabytes on Canvas. And I'm already at like close to 20%. So I'm gonna have to watch. I don't know if I can keep doing this with the screenshots, but anyway, we'll figure something out. So we didn't actually do anything on sheet 1.3, so don't worry about it. We'll worry about it tomorrow. We'll go ahead and I'll show you the metric game. If you want to look at, I think it's available now. If you want to take a preview of it, there's a video you can watch in the Canvas if you're, gung ho about getting started. There's no reason to, but if you really want to, if you're bored tonight and you want to get started on it, you can watch this video. It's old school. It's not a silent help video, so it's not quite as efficient, but it's me playing the metric game. But we'll play it together in class tomorrow. Okay, so what else we got? The last thing then is to talk about what homework is. You need to submit your exit quiz number 4. That is due tonight at midnight for full credit. I suppose if you turn it in tomorrow, I guess I have to look and see how that Canvas works that, whether it takes off 5 or 10% or something. Or may not accept it actually after today. Now, also, I just finished writing your quiz 5 this afternoon. So you get 2 attempts, and that's it, 2 attempts. It's available until Sunday. I've noticed that some students are already turning it in. One student already turned in a second attempt, so I guess that's it for him. It's only worth 15 points, which is a lot when it comes to quizzes, because they're worth anywhere from 3. I think one was 5, one's 10, one's 12, and now this one's 15. And it has to do with graphing and stuff. Okay. Also join ASCII's Physics Fall 2020. We're at 68, I think. So we're getting there. We got to get to 100 for us all to get the those 10-point bonus. I've extended that deadline. And then sheet 1.2 is due tomorrow night by midnight. And just take a pic of each side and submit that. I've already had about 10 people, well, maybe 5 to 10 people submit that. Okay, and you have infinite number of resubmissions until the deadline. And then we'll see what happens after that. Okay, that's it. I'll see you guys tomorrow.